center. Today we'll complete this theory. In school they have started new chapter?
No, sir. We started with center of gravity recently.
No. In school they have started what?
Yeah, in my school, no, not another chapter in school. We're still on this chapter in my school.
They are also on the same chapter.
Yeah.
Okay. Right heading, center of gravity. Center of gravity. First, what is meaning of word gravity? The force. What is meaning of gravitational force? The force by which a body is attracted towards center of earth is called as force due to gravity. The force by which a body is attracted towards center of earth is called as force due to gravity. Okay? Hello? Hello?
Yeah, sir. Understood.
Just write this much, then I'm clearing this to explain what is meaning of center of gravity. So far I came to know gravity is nothing but force by which body is attracted towards center of earth. The force by which body is attracted towards center of earth is called as force due to gravity. Once you are done with this, then tell me so that I can explain you what is center of gravity. Shall I clear this?
Yeah, sir.
Do you know our weight acts where, or weight of any particle acts where? Vertically downward or horizontal or any direction?
Vertically downward.
Okay. So this is one rigid body. Rigid body. Suppose it is made up of many particles. M1, M2, M3, M4, M1, M2, M3, M4, M5, and so on. So this all will have weight acting downward, na? In downward direction, na?
Yeah, sir.
Vertically downward, vertically downward, vertically. So if this is a center of the imaginary body, I call this as center of gravity and denoted by G. Then can you tell me what is moment of force due to gravity? See, M is mass. Then mg, can I say mg is force due to gravity? Saksham?
Yeah, sir.
Mg is force due to gravity. Now this force into perpendicular distance from this point of rotation is called as moment of force. So it is found that at some point सबका moment मिलके cancel हो जाता है. That means our body is said to be balanced at this point. Balanced means if this is creating anti-clockwise, this will create clockwise. No net moment, body is in equilibrium or balanced. So point at which moment of gravity due to all the masses cancel each other. What is that point called? Center of gravity. And that point is balanced point. Nora followed?
Yeah, sir.
Okay, वापस एक बार देखते हैं बस understand concept. This is the body. Here there is one particle, so its gravitational force will be mg downward. If I imagine this is balanced point, so this will give me moment, force into distance, correct? Same way here is particle, this will also give moment, this force into distance. If this anti-clockwise and this clockwise are cancelling each other, then at this point body is said to be balanced or not by condition of equilibrium.
Yes, sir.
So this point is called center of gravity. Yes, clear? Pakka?
Yeah.
Okay. So if they ask define center of mass, see, I will just show you one thing. I will also put the video on so that you will understand what is meaning of center of gravity. If I take this book and I rotate like this, it is not falling. That means that entire weight is balanced at this point. If it can move like this without falling, that means my body is balanced here. So that point where I can balance the body, why I can balance? Because whole weight is supported by my finger, which is pivot point or fixed point. That is called a center. Clear now meaning? So this way also it is not moving, and this way also it is not moving, neither clock nor anti, but in the circle. That is called as center of gravity. Yes, Aksham, you also followed?
Yeah. Yeah.
Can you all tell me center of gravity of a disc will lie where?
Of a disc,
Yeah,
it will lie the centermost point, sir.
it will lie at its geometrical center. If it is rectangular scale, then point of
The
intersection
geometrical
of
center.
diagonal.
Yeah.
So now if they ask define CG, that means center of gravity, how to write? See the definition, simple. The center of gravity of a body is the point, center of gravity of a body is the point about which the algebraic sum of moments of weight. Weight means force due to gravity. So moment of weight is moment of force due to gravity. Of weights of all the particles constituting center of gravity of body is a point about which algebraic sum of moment of weight of all the particles constituting the body is 0. The entire weight of the body can be considered to act at this point, howsoever the body is placed. That means whether you place the body, this is suppose one body, if here is center of gravity, so whether you place it this way or this way, center of gravity will be at same position. This is the meaning. howsoever the body is placed. Like if this is ring, this is center of gravity. If you place like this, same position where will be center of gravity. Followed meaning of center of gravity.
Yeah, sir.
Yes, please copy.
Yeah, sir, done.
Note we have to write regarding the center of gravity. They can ask you for 1 mark. First, the position of center of gravity, the position of center of gravity of a body of given mass depends on its shape. That means it depends upon distribution of mass. Like this is one body, this is center of mass. If I deform it, then this will get shifted to this point. So position of center of gravity of given mass depends upon shape. Second, it is not necessary that center of gravity is always within the material of the body. Meaning of this: if this is ring, then this is the material or some solid particle here. Center of mass is here, the gap, not on this material. But if I take solid sphere, then center of mass is in the material. So it can be in the material, it can be outside. This is the meaning of this. Copy the 2 point. Yes, can I clear this?
Yeah, sir.
Okay. One more point. Huh? Third, by concept of center of gravity. A body of weight W can be considered as a point particle. That means if this is body whose weight is W, it can be considered as point particle of weight W placed at its center of gravity. Can be considered as a point particle of weight W at its center of gravity. That means this entire distributed weight can be considered as a point where whole weight is supposed to be concentrated, because you can balance the body. Yes, third part clear? Center of gravity is like point where whole weight is supposed to be concentrated and body is balanced. Hello? Hello?
Yeah, sir. Yeah, sir. Got it.
Copy, third point. Yes, done, no?
Yeah, sir.
Now for different object, you have to remember their position of center of gravity. For different object, we have to remember position of center of gravity. Rod has center of gravity at midpoint. For rod, it is midpoint of the rod. For circular disc, it is geometric center. Then for solid or hollow sphere, it will be again geometric center of sphere. Fourth, solid or hollow cylinder, it is midpoint of axis of cylinder. See, if this is cylinder, then I'm drawing one line AB. What is this called as? X of cylinder. So perpendicular to this area is called area of cross section. The line which you draw, that is called actually axis. So its center is called center of gravity in case of solid or hollow cylinder. If this is cylinder, just tell me.
So the midpoint of the axis
Ah,
is running
so
through.
this is cross section. This axis is coming from. So don't get confused if it is kept vertical or horizontal. Where will be the axis? Where will be the center of gravity? Just copy this 4. 9 object you have to study. Written 4 points.
Yeah, sir.
Okay. Fifth, solid cone. Sixth, hollow cone. These two are big dangerous. Solid cone and hollow cone. For solid cone, it is at height h by 4 from base on the axis. For hollow cone, at height h by 3 from base on axis. Solid h by 4, hollow h by 3. Like if this is cone, this is called axis, this is called base. If it is solid, then from the base at distance of h by 4. And if it is hollow, then from the base at h by 3. This is base. 7th, circular ring. This is center of ring. 8th one important again. Triangular lamina. Lamina means plane. Triangular plane or scalene triangle. Means it is valid for any type of triangle. The point of intersection of median. Point of intersection of median. Point of intersection of median. 9th, parallelogram or rectangular lamina or square or rhombus. It is point of intersection of diagonals. Once you are done, please tell. Then,
Yeah, sir.
okay. Have you traveled by bus anytime?
Yes.
See, if it is luxury buses, then you might see that they keep the luggage this side, na? Here, not at the top. Have you observed that? They keep luggage at the bottom.
Yeah. Yeah.
And if it is ST buses, they keep at the top. So mostly ST buses, they overturn faster. Luxury buses, even though it appears to be huge, it doesn't overturn. Because by putting weight, always center of mass is close to the heavy mass. So when it is very close to the ground, center of gravity, then body will be acted upon by downward force. So it will not get overturned, but get pulled towards earth. So center of gravity, if it is more lower, then body cannot overturn. But if it is at top, then it gets overturned. So all these race cars, if you see, they are having their body mostly touching the surface. Huh? If you have observed carefully.
Yeah, sir.
So just for balance, just remember center of gravity should be close to the surface, not away from the surface. Last part of this chapter, circular motion, uniform circular motion. Uniform circular motion. Next class, first you will have test on force. You have to keep your video on. I will invigilate. You have to write the test paper, immediately send me half an hour test, and then we'll start with our chapter further. Okay.
Yes, sir.
How many types of motion you know? One is linear or translation motion. Second is rotational motion, correct? Yes or no? Hello? 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 You can't hear?
Yes, sir. I had a little.
If the body is stationary and free to move, when we apply force, it will translate. That means it will produce linear motion. But if body is fixed or pivoted at a point and force is applied, it turns. That is rotational motion. Circular motion is small particle moving along circumference of circle. Not the whole body turning. It is just particle moving. So motion of a particle along circumference, motion of a particle along circumference of a circle. is called as circular motion. So if this is circle and particle goes from P to Q to R to S along circumference, what is that motion called? Hello?
Circular motion.
But our heading is uniform circular motion. First write this, then I am explaining what is uniform circular motion.
Done, sir.
What is difference between speed and velocity? Difference
So
between
velocity can be zero because if it depends on the displacement. So if the displacement is zero, the velocity as well is going to be zero. But as speed depends on the distance traveled, distance is not going to be zero. Therefore, speed can't be zero.
or in very simple I say velocity is a vector quantity and speed is scalar quantity. If direction changes, then velocity will change, even though magnitude remains constant. Correct? Hello?
Yes.
So if P, Q, R, S are position of particle along circumference of circle, what will be the direction of velocity at P if body is moving anti-clockwise? Can I say this way? Along the tangent?
Yeah.
Now I'm drawing tangent to all the particles, all the position. You have to check the direction whether it is same or different at every. One tangent I am drawing to this point P of same length. That means magnitude is same. Then at Q, same way tangent at R, tangent at S. If they all have same value, 5, 5, 5, 5, then speed is same, no, throughout. Hello?
Yeah, sir.
What is changing? Direction, correct? So motion along circumference of circle with constant speed is called as uniform circular motion. Direction will keep on changing, magnitude will not change. That is called circular motion. So I can say like this, if they are defined circular motion and represented by diagram, defined uniform circular motion, define uniform circular motion. This is the topic where the student generally make mistake. So please be careful. Any doubt, ask. Motion along circumference of circle with constant speed. is called as uniform circular motion. Any doubt? Hello? Any doubt?
No, sir.
So can I say in uniform circular motion, velocity keeps on changing because direction is changing. Okay, write the definition. So if they say what changes in, you see a velocity changes in uniform circular motion.
Yeah, sir, done.
Yeah, okay. Do you know meaning of acceleration? What is acceleration? Hello, what is acceleration?
The constant change in volume with time.
Volume, velocity.
Sorry, velocity at time.
V is for velocity. So in case of uniform circular motion, velocity is constantly changing due to change in direction. Hello?
Yes.
So can I say always uniform circular motion will be accelerated?
Yes.
Okay. So if they ask distinguish between uniform circular motion and uniform linear motion. Uniform circular motion, uniform linear motion. So first I can write in uniform circular motion, speed is constant, but velocity changes. Here in uniform linear motion, both speed and velocity remains constant. Second point, it is always under acceleration, and here you will write acceleration is 2 point. Can I clear now?
Yeah, sir.
Okay. See, this is circular motion. That means circumference of circle. Hello?
Yeah, sir.
Yes. Saksham, can you hear me? Mic change kar lo na. This is suppose one velocity here, and this is another velocity. ये point P पे. Change in velocity is Nora what? What is change in velocity? What is change in velocity called as? Acceleration.
Yeah.
So what I do, this two straight line I am drawing here. This is one velocity, suppose v1, and from here I am drawing another velocity v2. So v1 plus change will become v2 or not? v1 plus change will give me v2 or not? Is it okay for you to understand this much?
Yeah.
This is what? Tangent or not? This is a tangent, huh?
Yeah.
So tangent and what is perpendicular? Tangent to the circle and what is perpendicular? Is it radius?
Center of, yeah, radius.
So if this is change in velocity, should be along radius. If tangent is our velocity, then this change, these two are at 90 degree. Now you will say, sir, how 90 degree? I will explain. This is which triangle? Which triangle is this?
Isosceles.
Correct. What about base angle of isosceles triangle? Is it congruent?
Yeah, they are congruent.
So can I say A plus B is 180?
Yes.
So 2A plus B is 180. If this B is very, very small, that means this angle is very, very small, close to zero, very, very small. So because for even smallest part, velocity is changing. That means if this is velocity, this is another velocity. For diagram purpose, I have drawn larger, but actually this change is very small. So this is isosceles triangle. This two is suppose AA. This will be B. So if B is close to 0, this one close to 0, then 2A is close to 90 or not? Tell me.
Yes.
So A is close to 90 or not? This is close to 90.
Yeah.
So if this is tangent, then this has to be radius. So along the radius, we are having change of velocity. Change in velocity means acceleration. This acceleration, which is acting along the center towards the center and along the radius, this is called as centripetal acceleration. What is centripetal acceleration? Hello? The acceleration due to change in velocity acting along the radius towards the center is called as what? Centripetal acceleration.
Velocity.
Velocity, acceleration. Centripetal acceleration. Again, I am writing what is centripetal acceleration. Acceleration produced in uniform circular motion due to change in velocity is always along radius and towards center. This acceleration is called as centripetal acceleration. Centri means towards the center, petal means along radius. So acceleration produced in uniform circular motion due to change in velocity is always along radius and towards center. This acceleration is called as centripetal acceleration. Copy definition.
Yes, sir.
Say understand and then write. Huh? If you are not understanding, ask me again. I will give many examples.
Done, sir.
Have you heard about Newton?
Yeah.
What Newton suggested? There is force required to produce acceleration. No?
Yeah.
So if you heard Newton's second law, it states that force is mass into acceleration.
Yes.
That means if there is change in velocity, there will be acceleration, and if there is acceleration, there has to be force. So if there is acceleration called as centripetal acceleration, there will be some force called as centripetal force. So the force which produces centripetal acceleration. That means indirectly change in velocity along circle. The force which produces centripetal acceleration is called as centripetal force. It is also directed towards center and along radius. It is directed towards center and is along radius. Yes, clear meaning? Hello? Hello?
Yeah, sir.
Okay, please copy this one then.
Yeah, done, sir.
Draw a diagram showing direction of centripetal force. Draw a diagram showing direction of centripetal force. Whether it is centripetal force or acceleration, direction will remain same. So this is circular path. Centripetal force is towards the center. So wherever you consider particle, it will act towards the center. It will act towards the center. It will act towards the center. So if this is P, this is the direction, this is the center. If this is Q, this will be direction towards the center. If this is R, towards the center. S towards the center. So this will be direction of centripetal force. Draw a diagram showing direction. Completed full?
Yeah, sir.
Okay. Examples of centripetal force. Satellite revolves in circular orbit around planet. Circle में turned means it requires centripetal force. The necessary centripetal force is provided by gravitational force. So gravitational force of attraction helps to change the direction, that is called as centripetal force. Same way when electron revolves around nucleus, then electrostatic force provides necessary centripetal force. Third example, a stone tied to string when world means revolve in horizontal circle, then necessary centripetal force is provided by tension along string. Means what? See, if this is string, centripetal force is pulling the body. Pulling force creates tension. Have you followed all the three examples? See, if I tie a stone here, its weight is pulling downward. That creates tension, if you know, studied from 9th. Hello? All the three examples clear?
Yeah.
Okay. Now, once centrifugal force is left out, then distinguish between them. That completes your chapter completely. First chapter. Okay.
Yes, sir, done.
Yes. Yes.
See, suppose you are traveling by bus or by car or by train or you are on moving chair. Whenever vehicle takes turn, what we feel, body is thrown outward. No?
Yeah.
So to throw we require force. So that means if you are traveling by bus, driver has made to sit somebody under the chair so that when the bus is taking turn, he will throw you out. Just it is our feeling. No? We are having outward push.
Yes, sir.
So that imaginary forces which we feel it is acting. See, अचानक अंधेरा हो गया तो अपने को डर लगता है ना. We feel there is something, but actually there is nothing. So that imaginary force, or it is so called pseudo force, which acts on the body when body is moving in a circle is called as centrifugal force. What is the name of this force? Centrifugal force. So if body is taking turn, then there is centripetal force. Simultaneously on the body there will be imaginary force which the body feels is pushing the body outward. That imaginary force, which is equal to centripetal force, is called as centrifugal force. Because असली force दो body के बीच में रहता है. Like if this is one mass, this is another mass, they will attract each other. When I say each other, मतलब दो है ना body. But single body experiencing outward push, मतलब ऐसा हो नहीं सकता है ना. दो चाहिए क्या नहीं? Hello. So such type of feeling which is developed when you are performing circular motion is called as centrifugal force. असली में होता नहीं है. Body feels that it is thrown outward. So, and imaginary force experienced by a body when imaginary force which acts on the body when body is performing circular motion in radially outward direction is called as centrifugal force. One.
Yes, sir.
See, have you heard about washing machine? Have you seen washing machine?
Yeah.
In that washing machine, the cloths when are put, then see, at then थोड़ा आवाज जैसा आता है. So this cloth is thrown outward, so that through this pores, na, water comes out, and cloth gets partially dried up. Partially. That is nothing but due to centrifugal force. If buttermilk is stirred, then cream comes upward and floats. That is due to centrifugal force. If I place a coin on the disc and rotate it, coin is thrown off, no?
Yeah.
That is nothing but centrifugal force. So, force which comes into play on the body when it is performing circular motion is actually called centrifugal force. Its magnitude is same as centripetal, but direction is opposite. Last part of the chapter
Sir, I
is
have a question. The
uh,
experiment explanation and conclusion part is omitted, right?
which one? Yeah, it's omitted. Distinguish between but I have explained you almost everything. And centrifugal force. So this is 2 points for centripetal force and centrifugal force. Very important. 2 points for 2 marks. First, it is real force, and this is fictitious or imaginary or pseudo force. We can say it is fictitious force. Fictitious means imaginary or also called as pseudo. It is directed radially inwards. It is directed radially outwards. Right, this 2 point. Now, nothing they can ask out of whatever I have taught in your exam.
Done, sir.
Okay. So this completes your chapter completely. Coming Tuesday, I will keep one test for you. And after test, I will